So, good morning, good afternoon, everyone. The numerical methods we did today, we are discussing here the truncation error. What is the truncation error? The truncation error here we are seeing the truncation error we are seeing here. This refers to the approximation is numerically solving mathematical problem, and this the error generally associated with the subject of numerical analysis. Yesterday we discussed the approximation is infinite process of the by finite ones by replacing non-computable problems with suitable computable ones. If sufficient is taken, such errors can lead to be blunders. So consider the infinite summation of n is equal to 1 to infinity 1 by n. We are taking here. So therefore, working any specified accuracy. That is accuracy means we are taking summation of n is equal to 1 to infinity. Therefore, sufficient accuracy we can take here. So therefore, the series appears to converge. So two decimal places of the correct rounding here. Then each term n is equal to 200 we treat it as 0. So that we can write summation of n is equal to 1 to infinity. And by n we can write summation of n is equal to 1. N is equal to infinity, we are taking that 200. So summation of n is equal to 1 to 201 by n, we can treat as that is 6.16. We can take that value here. But the series, the summation of n is equal to 1 to infinity, 1 by n they are divergent. So 1 by n is divergent here, but it's a convergent and divergent to in the real analysis. So the difficulty is the traction of partly by rounding error. In order to claim that the finite number of terms gives the sum of an infinite series, here a specified accuracy. You must ensure that all the remaining terms in the series do not affect the same accuracy. So modeling error. What is a modeling error? A mathematical model for a physical situation and an attempt to give mathematical relationship between certain quantities of physical interest. Because of the complexity of physical reality, varieties of assembling assumption used to be consist of more tractable mathematical models. The resulting model has limitations on its accuracy as a consequence of these assumptions, and these limitations are maybe not trouble. So depending on the use of the model, in this model is not sufficient accurate here, the numerical solution, what we are taking the values here, the model cannot improve upon the basic of lack of accuracy. So Taylor expansion here. The Taylor expansion, one of the most important Taylor's tool, one of the important tool is numerical analysis, that is the Taylor's theorem and the associated Taylor series. The theorem gives the relativity simple. On the method of approximating functions, we are taking it f of x polynomial by gives a method for computing f of x. So we are calculating the value of x by the Taylor theorem. So we are taking the f of x, n continuous derivatives in a comma b, n greater than 0 x comma x naught belongs to AB. So we are taking the value a, b, n greater than or equal to 0, small n greater than or equal to 0. We are taking f of x is equal to Pn minus let's say x plus Rn minus x. What is here? R means the unlimited number. Rn x we are taking here. So therefore, Pn minus 1 x we are taking, Pn minus x we are taking here. See all of you are Pn x means f of x naught. First one x minus x naught by 1 factor. Second one we take that x minus x naught by 2 factorial and double dash. Next 3 factorial by triple dash and so on. And so on we are taking here. So on x minus x naught by n minus 1 factorial. X minus x naught power n minus 1 by n minus 1 factorial. F of n minus 1 x naught. So Rn x, what is the nth value we are taking here? Rn x we are taking here 1 by n minus 1 factorial. Integration of x naught x minus n minus 1 f of n t dt. X minus x naught by n factorial n f of n zeta for some by x naught x value we are taking here. Rn is the remainder. Already told the nth term that is the remainder of after n term. The remainder term is the quantity the more interesting. So therefore, the error term in interpolation polynomials Pn minus x will be taken an approximation to x. For this approximation to be any real value must to Pn minus x stands to f of x, that is n stands to. It will then follow the any required tolerance epsilon. So there exists Pn minus 1 f of x less than epsilon we are taking here, n minus 1 greater than n, and therefore Pn would be the suitable approximation. Obviously, we do not like to know work done necessary. So therefore, n is the which condition is essential, the finite differences. So finite differences, see here I am taking the table, the forward difference operator delta, operator delta. So what we are taking here, the forward difference operator delta is defined by del yi. So del y plus I1 minus, and what were second value minus first value. Del, see here all of you, the second value is the first value yi. Del yi is called the forward differences of yi here. So del r plus yi, so del power r of yi plus 1 yi. So del ry plus 1 del yi. So del power 0 yi is equal to y. So del ry is called order forward difference of y we are taking here. So see all of you here again. X naught, x1, x2, x3, x4, y naught, y1, y2, y3, y4, xy. Del y. What I am taking del y here, see here. This is y minus, this is y2, y1 minus y0. I am already told in the beginning. So del y0, first condition y1 minus y. Then y2 minus y1. Then y3 minus y2. Then y3 minus y4. So this is called, this beginning called as del y0. Again, I'm clearing these words. Here I'm not drawing. So this is called del y0. This is called del y1. This is called del y2. This is called del y2. Again, I'm clear. I'm telling you. See here, del y1, del y2, del y2. So this is the del square. So del square means del y1 minus del y0. This is the one. So del cube y0. So this is del square y1. So del square y1 take that. Del square y1 means del square y2 minus del square y1. Again, we are doing del cube y3 minus del y2. So these are, we are clearing the del cube y0. So del cube y0 means, you see here, del square y1 minus del square y1. So del cube, again del cube, del square y2 minus. So I'm taking this is a delta function. This is del square, then del cube. So then we are doing here, then we are doing del 4 y0. What is a del 4 y0? Del cube y1. What is del cube y1? So only one term here. Only one term here. This is a square term is there. So del cube y1 minus del. So అంటే మారిపోతుంటది విలువలు 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 మారిపోతుంటాయి విలువలు మారిపోతుంటాయి సో అప్పుడు మనం తీసుకోవాల్సి వస్తుంది ఒక ఎగ్జాంపుల్ తీసుకున్నాం from the difference table 0 0 1 1 2 8 3 27 4 64 identify del square y0 del square y1 del square y2. See here, this is another way. First x1 0 say 1 0 1 2 0 1 2 3 4. I am written here 0 1 2 3 4. Second one 0 1 0 1 8 27 64 0 1 8 27 64. So I'm clearing your values. So again, another here. So 1 minus 0, 1. 8 minus 1, 7. 27 minus 8, 19. 67, 4 minus 27. 64 minus 27 means 30. 34. 34 plus 37 we are taking it, 37. Then again, 7 minus 1, 6 del square. 19 minus 7 means 9 plus 3, 12. 30, 20. 20 means 18. So 12 minus 6, 6, 18 minus 2, the value del 4y value is 0 we are taking here. Again, so what is the values we are writing? Del square y0. So del square y0 is see here. Del square y0 is del square y0. This is the value of del square y0 6. Del square y1. This is the value of 12. Del square y12 is 19. See here the y2, y0, y1, y2, y0, y1, then y0. So these values are perfectly we are writing here. So therefore we are writing these values here. So observe the given data y is equal to x cube on the third degree polynomial. The third difference del cube in the table or constant is equal to 6, and the fourth order difference is del square del cube del 4 y0 is 0. We are taking that value here. Just a minute. backward difference operator nabla. So we are taking here nabla here. The backward difference operator is defined by nabla yi is equal to yi minus yi minus 1. So therefore, del nabla means we are writing the symbol nabla r plus 1 yi is equal to nabla r yi minus nabla r yi minus 1 r greater than 0. Nabla 0 yi is equal to y. The backward difference table is written as x0, x1, x2, x3, y0, y1, y2, y2. Already I told that x0, x1, x2, x3, x4. So here nabla is equal to, there is a different value. So y1 minus y0 same, y2 minus y1 same, y3 minus y2. So the same del y2 minus y1. Here we are taking the lowest values. Here taken the, earlier we are taking the del y1 values. Here taking del y2 values. Here del y2 minus y1. Here del y3 minus y2. Here del square y3 minus del y2. Nabla, sorry, nabla y3 minus y2, nabla y2 minus nabla y1, nabla square y3 minus nabla square y2 values we are taking in this condition. So del y0 is equal to del y1, del square y2 is equal to del square y0. So we are taking the values from that one. Shift operator. The shift operator EYI is equal to yi plus 1, e power r y is equal to yi plus r greater than 0, e power 0 y is equal to yi. So the e will shift I the next value yi plus 1, where x is any rational number, h is the interval difference. Averaging operator mu is equal to 1 by 2 e power 1 by 2 plus e power minus 1 by 2. So u of y naught, what is u? We are taking 1 by 2 y 1 by 2 plus y minus 1 by 2 we are taking it. So what is the condition? Consider a function here. Consider a function y tabulative value. We are taking the spaced arguments. What is the arguments? x0 plus x0 plus x0 plus 2h, x0 plus 3h, and so on. So the behavior of the velocity x0 plus r plus h, we take the transformation here x0 minus x0 plus r. So what is x0 plus rh will become y0, the interval of the difference in 1. The table we are taking here. What is the central value? 0. What is the central value we are taking here? x0 plus rh is equal to 0. What is the central value? x0 plus rh is equal to 0. In the front side, we can write in the upper side values minus, in the lower side values we can write minus plus values. So x0 plus rh is the middle value, that is 0. You have to see here. There is a 0, x0 plus rh value 0, x0 plus r minus 1 h is equal to minus 1, x0 plus r minus h 2, x0 plus r plus 1 h y1, x0 r plus h is equal to 1. So the upper values is minus and lower values is positive values. So automatically we are writing y minus 2 and y minus 1, y0, y1, y2. So that is this is called as del y minus 2. This is called del y minus 1. This is called del y0 and del y1 and del y. So just del y1 and del y. So del y minus 2. So these two values are del square minus 2. These square del square minus 1. These two del square by 0. So these are very simple in here. There's a very simplification. Del square del 4 power minus 2. What's the values? The output values may be. These differences can be expressed in terms of the central differences by the central difference operator. The central difference operator delta is defined as delta is equal to e power 1 by 2 minus e power minus 1 by 2. So we are taking e power 1 by 2 minus e power of minus 1 by 2. We are taking delta e power 1 by 2. That is, we can call delta e power 1 by 2. We can call as e minus 1 into delta. So what is e minus 1? So del of y minus 2 is equal to delta into e power 1 by 2 minus 1 by 2. That is also called our right delta of y. In place of y we are writing y of minus 3 by 2. So that is our conditions. We are writing del y minus 1, del y minus 1 by 2, del y dot is equal to del 1 by 2. This is the conditions of this one. So take the one, take difference table and taking the delta. This table is called as central difference table. And the central difference table already told you x0 plus rh is equal to 0. Then I'm taking the 0, minus 1 and minus 2 here, 1, 2 taking m here. So minus 2, minus 1, 0, y0, y1, y2. This is the simplification of minus 1 by 3 to minus 1 by 2. The 0 value delta 1 by 2, 3 by 2. These two simplifications del square minus 1, del square y naught, del square 1. These two simplifications del square minus 1 by 2. These two simplifications del cube 1 by 2. These two plus 1 by 2 and minus 1 by 2 is the values delta power 4 y naught. So this is the value of this one. It should be observed that the numbers in the corresponding positions in the two or tables are the same. The schemes differ only by notations. Relations between the various difference operators. So what is the difference operators? What is the various of the difference operators from the definitions delta and nabla? It can be proved delta and nabla or linear operators. Delta is equal to f of x plus g of x. So that f of x plus g of x, what we have to write in the next column, delta of f of x plus delta of g of x. We are simplification, separating. So then delta of C of f of x is equal to, C is the constant number we are writing in the first. So C of del f of x. So nabla of f of x plus g of x, we are also saying nabla of f of x plus g of x. C nabla of C of f of x, C we will take the constant in front. So C is nabla of f of x. So delta f of x. So what is the delta f of x? So f of x means I am writing f of x plus h minus f of x. F of x plus h means I am writing that is E f of x minus f of x. E f of x means what is the value? E f of minus 1 f of x. So in terms of delta is equal we can write e power e minus 1. E minus 1. So therefore also delta f of x minus h. So therefore f of x minus f of x minus e inverse of f of x 1 minus 1 by e. So f of x minus f of x plus h minus f of x, e of f of x minus f of x, e minus 1 f of x. So in terms of delta is equal to e minus 1. So nabla f of x is equal to f of x minus h. So therefore f of x e inverse f of x. So therefore 1 minus 1 by e f of x. We can write that the LCM part we are taking e minus 1 by e. So there 1 minus 1 by e f of x is equal, we are taking the alternative e minus 1 by e f of x. So therefore nabla is equal to 1 minus e inverse. So nabla is equal to delta by e. So e of nabla is equal to e of nabla, we can multiply the cross multiplication of delta. E minus nabla is equal to delta. From the Taylor expansion here, yx plus h is equal to y of x plus h y dash x plus h square by 2 factorial y double dash x plus h cube by 3 factorial y triple dash x. This can be written as e of y of x is equal to 1 plus hd by h square by 2 d square y f of x. So hd by x where d is equal to d by x. Our terms of operator e is equal to e power h. From the definitions of mu square is equal, we can write 1 by 4 e plus e inverse plus 2. E power e inverse. So therefore 1 by 4 e power 1. So I am taking the 1 by 4 is a constant automatically. That is a e plus e power minus 1 by 2. There is a plus b whole square. The formula we are writing here e power 1 by 2 minus e power minus 1 by 2 whole square plus 4. So this is a, we can write e power 1 by 2 minus e power minus 1 by 2 plus 4. We can write this function 1 plus delta square by 4. So mu square is equal to 1 plus delta square by mu square is equal to 1 plus so mu square is equal to 1 plus delta square by 4. So mu delta is equal to 1 by 2. The condition above condition e power 1 by 2 plus e power minus 1 by 2. We are taking a plus b and a minus b. So a plus b and a minus b, what we are taking 1 by 2 e minus e inverse. So 1 by 2 1 plus delta minus 1 by 1 plus. So the e, what is e power minus 1 means 1 by 1 plus delta. E means 1 plus delta. This is a simplification. What I am doing del by 2. I am taking take the LCM. So that is the value is mu delta is equal to delta of e power minus 1 by 2 plus delta by 2. So the conditions e delta nabla we have to prove here these conditions. Difference of polynomials. Let y is equal to x be a polynomial nth degree. So therefore y of x is equal to a n xn plus a n xn minus 1 plus a naught a n not equal to 0. A n not equal to 0. Then the first difference is del y, which when h, the interval of differencing is a constant, del yx is equal to yx plus h minus yx. So an x plus hn minus xn plus an minus 1 x plus h n minus 1 minus x power n minus 1 a1 plus x h minus x. So this is a simplification value we are writing. This is a polynomial of degree. This is a theorem. One example we will take it. Example 1 we have to take it. Using the tabular table, y0 is equal to -5, y1 is equal to -10, and y2 is equal to -1, y3 is equal to 4, y4 is equal to 5. Obtain y5. So what is the values given? 0, 1, 2, 3, 4, 5. First condition is what is the values? How many? 1, 2, 3, 4, 5 values given. So first, what is the values here? I'm writing here: -5, -10, -9, 4, 35. The values is given. -10 plus 5. This is -5. -9 plus 10. Minus into minus plus 1. So again, I'm telling you. So 4 plus 9 minus into minus. 35 minus 4, 31. So 90 minus 35, 40, 55, around the value. Again, I'm taking here 1 plus 5, 6, 13 minus 1, 12, 31 minus 30, 18, 50, 24, 12 minus 6, 6, 18 minus 12, 6, 24 minus 18, 6. So this is the value of the numerator. This is the values of the table. So these one, we are taking the values of the value. So making use of the conversation of this one, above you can conclude the data of the third and third order difference or consistence of the table wise. Then again, del 4y. Del 4y what means? 6 minus 6, 0. 6 minus 6, 0. Del 5y, that is also the value is 0. So assuming here, we are taking del square y2. What is del square y2 here? Del square y cube minus del square y cube. So del square y cube means 18 minus. So del square y cube minus del square y cube. What is del square y cube? Del square y cube means we have to write here 6 plus 12. So here there's 18 plus 6 here, 18 plus 6 we can taking here, 18 plus 6, 24. The value is total 35 plus 5 is equal to 90. So what is the values we are coming here? We are writing here. But this is the method, the estimating of the value in the tabular form of the expression. Finding the missing value of y3 using the data, y0 is equal to 580, y1 is equal to 556, y2 is equal to 520, y4 is equal to 385. Given the data is converted to a cubic polynomial. As it's given, the given data represent a cubic polynomial order of the y constant del power 5, 4 is equal to 0. So del power 4 y is equal to 0. What is the condition? What is the formula? Already told you, e minus 1 whole power y naught is equal to 0. I'm expanding e minus 1 whole power y naught. I'm expanding here e minus 1 whole power. So e power 4 minus 4e cube plus 6e square minus 4e plus 1 y naught. Or e power y naught, I'm multiplying with y naught for e power 4 y naught. 4e cube y naught plus 6e square y naught minus 4e y naught plus y naught is equal to 0. So this is the y54, y2, y1 as y3 for 65 value. So this is the value of, you can finding the values the same here. The interpolation. Interpolation formula is in the major interpolation formula, Newton's forward interpolation formula. Let y is equal to f of x be a function whose expletives may be known as take the values of y0, y2, yn, the corresponding to the equivalence and distinct values. There is x0, x1, x2, x3, xn, and so on, that they require to find p of x a polynomial of degree, and then almost p of x is inside the tabulated points. Assume the polynomial in the form. What is the assumed polynomial? P of x is a0, a1 plus x minus x0, a2, x minus x0. Until we are taking the second value, we are writing x minus x0, x minus x1, x minus x2, and x minus x3, and so on plus an. At the nth condition, we are taking an, x minus x0, x minus x1, x minus x2, and so on, x minus xn minus 1. So we are taking the 2, a2 means we are taking up to the 1th condition. We are taking 3, condition 2, 4 condition, we are taking x minus x0, x minus x1, x minus x2, x minus x3, then x3 condition we are taking. Now employ some coefficients a0, a1, an are determined such that p of x0 is equal to y0, p of x1 is equal to y1, p of xn is equal to yn. Conditions are satisfied. Let x0 is equal to x0 plus r. It already told that r plus h is equal to 0 condition. So therefore x0 is equal, x is equal to x0, substituting in this above the third condition here. So therefore p of x0 is equal to y0 is equal to a0. Therefore y0 is equal to a0. X is equal to x1, substitute here y1 minus y0, y1 minus y0. So see the earlier table, y1 minus y0. In the table we have to see here y1 minus y0, del y1 here. So again here I'm showing here the same practical method here. So y1 minus y0 means del y by h. So another formula x is equal to x2, a0 plus a1 x2 minus x0, a2 x2 minus x0 minus x2 x1. So therefore these values y0, y1 minus y0 by h plus 2h by 2h by h we are taking here. So therefore we are taking these conditions here, substituting. Similarly, a cube is equal to 1 by 3 factorial by h cube, and so on. We are taking the value. So finally we are taking p of x is equal to y0 x minus x0 plus del y0 by h del y0 h plus x minus x0 x minus naught x minus x1 del square y0 2 factorial by h square by h square. So the conditions is going on. X minus x0 del y0 by h, x minus x0 x minus x1 x minus x2. You can write del cube by y0 3 factorial by h cube. So conditions will be going on. X minus x0 x minus x1 x minus x2 x minus x3 x minus x4 x4 del power y power del power del cube by y0 by 3 factorial by h square. You can write here x minus x0 x minus x1 and so on x minus xn minus 1 del power n y0 by n factorial by h. This is a Newton forward interpolation formula. The formula may be written in simplified form to change the variable. P of x is equal to y0 is equal to u of del y0 plus u of u minus 1 by 2 factorial to del square y0. So u minus 1, what is the u value means? We have u means x minus x0 by h is the u value. The u 0 less than u less than 1, the integral we are taking. U minus 1. So we are taking the table. The values is del square y0, del cube y0, and del yn mod. This is called as Newton forward interpolation formula. The Newton formula for backward interpolation. What is the backward interpolation? For estimating here, the values of y corresponding to the value of x near the method of tabular form. Usually Newton interpolation, backward interpolation formula. So the derived below is assume the polynomial represent the given data xi comma y, small xi comma y is equal to 0, 1, 2 n. Px is equal to a1 plus x minus xn. And the reverse backward interpolation formula in this column a1 x minus x0 x minus x1. We are taking here in the starting condition a1 x minus xn, a2 x minus xn x minus xn minus 1, and so on x minus xn x minus xn minus 1, and so on x minus xn. So one can determine the coefficient a0, a1, a2, an, so such that we can write pxn is equal to pyn, pxn minus 1, yn minus 1, px0 is equal to 1. This is in the formula of nabla. A0 is equal to yn, a1 is equal to nabla yn by h, a2 is equal to nabla square yn by 2 factorial by h square, an is equal to nabla yn by yn, n factorial by h. So this is the formula condition I am using here. P of x is equal to yn nabla yn by h x minus xn, nabla square yn by 2 factorial h square x minus xn by x minus xn minus 1, and so on nabla yn, n factorial by h and x minus n, x minus xn minus 1, and so on x minus xn. This is the putting the values in the same of the earlier on Newton interpolation, forward interpolation formula. A u is equal to x minus xn. Here, forward interpolation for the x minus x0 by h. Here we are using u is equal to x minus xn by h. So yn is equal to u plus del 1, nabla yn, u plus 1 by 2 factorial, nabla square yn. So plus 1, u plus 1, u plus 1, so on u plus n minus 1 by n factorial, nabla yn. This is called one backward interpolation image interpolation formulas. Pi of x is equal to 0, pi of x is equal to p1 minus p2x to the degree n at most, and would have n plus 1 0, so x0 x and x. Another example we are taking here. Obtain a polynomial approximation u of x data u0 is equal to minus 5, u1 is equal to minus 10, u2 is equal to minus 9, u3 is equal to 4, u4 is equal to obtain, hence obtain u 0.5. So u, what is the 0.5? So they given the data u. So therefore, how many numbers given? 1, 0, 1, 2, 3, 4. 0, 1, 2, 3. What the values they given here? Minus 5, minus 10, minus 9, 4, 35. They have given the value. So minus 10 minus 5. 10 plus 5. 5. Minus 10 minus 9 plus 10. 1. 4 plus 9, 13. 35 minus 2, 31. 1 plus 5, 6. 13 plus 1, 13 minus 1, 12. 31 minus 3, 18. 12 minus 6, 6. 18 minus. Only 4 values they are asked delta Q. See the fundamental, the Newton forward interpolation formula. The polynomial of x is equal to 0.5. Here it is equal to 1 del cube ux. Is the constant of all higher order differences are 0. Polynomial will be of the third degree. So therefore, u is equal to first condition. What is the first condition? Del u of x is equal to minus 5. I am writing here. So condition x minus 0. First condition is x minus 0. This is a x minus 0. I am writing here. Then x minus 5. X minus x0. Then x minus 5. So x minus 0, x minus 1 by 2. What is the first value here? That is the first value here. First value is the 6 here. I'm writing the 6. Then x minus 0, x minus 1, and x minus 2, the value is 6. So therefore, I'm writing that is a simplification that x cube minus 6xy. U 0.5. So the U 0.5 means 0.5 whole cube minus U 0.5. This is the 0.5 whole cube. I'm writing 6 into 0.5. The simplification is 7.8. So in place of x, of the finding the equation, in place of u, we are finding the values u is equal to that value. And then use Newton backward interpolation formula. The polynomial approximation, the given data uniqueness of the interpolation formula. The population of the town follows. Year 1941, 1951, 1961, 1971, 1981, 1991, 20, 24, 29, 36, 46, 51. The Newton backward interpolation from 1975 and find that during the 1975 to 1981. So xn is equal to what is the highest value? 1991 I am taking. What is the lowest? What is the 1975? What is the 1975? So in the given that the Newton backward interpolation 1975. So find the increasing of 1975 to 1981, 75, 85. So I'm taking a 75 to 85 here. So therefore h I'm taking x minus x minus 75 to 91. 70. This interval is 41, 51, 61, 71, 81, 91. These interval is 10. This interval is 10. So x minus 1975 minus 1991 minus 1.6 right here. The value is 1941 to 51, 61, 71, 81, 91. The values are given here. The values are given 20, 24, 29, 36, 46, 51 given. 24 minus 24, 29 minus 24, 5, 36 minus 29, 7, 46 minus 10, 51 minus 46, again 5 minus 4, 1, 7, 5 minus 2, 10 minus 7, 3, 5 minus 10 minus 4, 2 minus 1, 1, 3 minus 2, 1, minus 5, minus 3, minus 8, 1 minus 1, 0, minus 8, minus 1, minus 9, minus 9, minus 0, that is a minus. I'm writing it. So we are take the simplification of the applying the Newton backward formula here. So why 7? They are asked that what they're finding asked here 1975. They're asked 1991. What is the formula 1975 up to? So therefore 1991 we have to find here. So 1991 we have to find here 1991 u plus 1 but del square nabla square 1991 u plus 1 u plus 2. So up to the condition they have given here up to the condition del y phi. So del phi y we are finding the value nabla phi y nabla y nabla square by nabla cube by nabla 4 by nabla phi y. So u plus 1 u plus 2 by 4 factorial u plus 1 u plus 2 u plus 3 u plus 4. So first y 1991 what is that value? 51 they have given here. So I'm writing here 51. Very good. So what is a u? What is a y91? What is the y value we are finding here? Minus 1. Minus u value minus 1.6. Minus 1.6 here. Minus 1.6 into 5. So minus 1.6 into 5. Then u into 1991. Minus 1.6 into 0.6 into minus 5. So we are minus 1, minus 5, minus 8, minus 5, 5. Here in the table we are writing minus 9, minus 9, minus 8, minus 5, y. We are taking the values here. So therefore minus 1.6, 0.06 into 4 into minus 8. So therefore all the simplification we are doing that is 39.70. So the population of 1975 was 39.79002 as per the table formula. So increase the interpolation 1975 to 1981. So therefore what is the given here? What is the given here? 1981 is 46 here. So 1981 is 46. So therefore 46 minus 39.2. So 6 lakhs is increasing with the population 1975 to 81. So this is one of the values we are finding here. So another given that x naught is equal to 35, 37, 39, 41, 43, 45. Y is equal to 0.70021, 75355, 0.80978, 86929, 93252.1. This is the Newton interpolation formula. Exportable y47, y49, y50. So these one are we are rating x naught 35, 35, 37, 39, 41, 43, 45. 43, 45. Use intended to obtain y in 540, y47, y49, y50. So y value is given here 7022 up to 45, they have given 0.1. 721, 75353 into division we are in. So from the difference table, the decimal point, the understanding that the values given of the decimal places, the tabular values in the problem, and hence the fifth order difference is constant, higher order difference is 0. Using that to explode the 47 degrees and 51 degrees in the table, we're taking the formula and applying the same here. We are finding the y47. So this is the same ones for the same. Now we are going to the central differences. When the data given equally spaced at the value of x, you have used forward and a backward difference interpolation formula if the interpolation desired near the beginning and respectively of a table values. When you are required to interpolate of values near the middle of the given tabular form, you need to obtain formula appropriately. Gauss central difference formula. What is Gauss? In the Gauss central difference formula, Gauss forward formula. The Newton forward interpolation formula is given by y is equal to y naught, u del y naught, that is u into u minus 1, 2 factorial del square y naught, u minus 1, u minus 2 by del 3 factorial del cube y naught, u minus 1, and so on, u minus n plus 1. That is up to going on the del naught, del power n y naught. So where we x is equal to x naught plus hu, or u is equal to already I told you x minus x naught by h. So therefore del square y naught is equal to del square y minus 1 del cube minus 1. So we have simplified them with the same problem, the values the same one. So here the central difference table, you have to take the central value 0, 1, 2, 3, minus 1, minus 1, minus 2, minus 3. Negative values show in the up and the positive values in the down. So see here y3, y minus 2, y minus 1, y0, 1, 2. See here very y3 minus 2, y del y minus 1, del y0. So see here del y minus 1, del 0. These two 1, del minus 1, del square y0. Then again del cube y minus del cube y minus 1, del 4, del cube, then del 5, del 5, del 6. The value should be increasing here from the table of the central difference table. The Gauss backward formula. So in the same Gauss forward formula, y is equal to y naught u of 1 del y 1 2, u2 del square y10, u plus 1 by u plus 1 3 del square by power 1 by y1 by 2, del cube by 1 by 2, del u plus 1 by u plus 1 4, del power y naught, u plus 2 5, del power 5 1 by 2. These values are formula. This is a Gauss backward formula. The Newton forward interpolation formula is with the Gauss backward formula. Y naught is equal to y is equal to y naught plus u del y naught, u into u minus 1 by 2 factor del square y naught, u into u minus 1, u minus 2 3 by del cube y naught, and so on, plus u into u minus 1, u minus n plus 1 by del n factor del naught y. U is equal to x minus x naught h. We have del y naught minus del y1 del is equal to, we can write del square y minus 1. Del y naught is equal to del y minus 1 plus del square y minus 1. So we are taking the left side here. Del square y naught is equal to del square y minus 1 plus del cube y minus 1. Del cube y naught is equal to del cube y minus 1 del 4 y minus 1. Del 4 y naught del 4 y minus 1 plus del 5 y minus 1. So this is the values we are writing here. Substituting the values in the above formula, del 4 y minus u y is equal to y naught plus u del y minus 1. U into u plus 1 del square y minus 1 by 2 factorial. U into u square minus 1 by del cube y minus 2 3 factorial. Plus into u square minus 1 into u plus 2 del 4 y minus 2 by 4 factorial. U into u square minus 1, u square minus 2 square del cube y minus 3 5 factorial. These are values we are finding here. The output is y is equal to y naught plus u1 del y minus 1 by 2, u plus 1 2 del square y naught, u plus 1 3 del cube y power minus 1 naught. So negative and positive. First, third, fifth is a negative. Second, even numbers are positive and odd numbers are negative. U plus 1 3 del cube y minus 1 by 2, u plus 2 4 del power 4 y naught. So this is the values of 10 to expansions here, y by 2 to y1 by 2 or y minus 1 by 2 here. The even numbers are positive and the odd numbers are negative. Gauss third formula. For the derivation of the Bessel's formula, we need the third central difference formula, that starts with y and runs parallel to the Gauss backward formula. To derive such formula, we advance the subscripts of Gauss backward formula x minus n h x naught and change use u minus 1 x minus x 1. The changes of amount advancing all subscripts 1 unit and replacing by u minus 1 reduces here. One reduces here y1 plus u minus y1 The changes of this one, the y is equal to y1 plus u minus 1 del y naught, u minus 1 del square y naught by 2 factorial, u minus 1 u minus 2 del cube y minus 1 by 3 factorial, u square minus 1 u minus 2 del 4 y minus 1. This is a Gauss reduces one. So y is equal to y1 u minus 1 del of y1 by 2, u2 del square y1, u3 del square 1 by 2, u plus 1 and u plus 1 c of 4 u plus 1 pi del power y del power pi y 1 by 2 is the value. So we can find how we can find the Gauss forward formula x is equal to 3.75 for the given data. The Gauss forward formula, so when the value of u, x equal to 3.75. X value is good 2.5, 3, 3.5, 4, 4.55. U value 24.145, 22.043, 20.225, 18.644, 17.262, 16.047. Take 3.5 as the origin. X is equal to 0.5. Define the new variable. T is equal to x minus 3.5 by 0.5. And we declare the value of u for which we are taking the value 3.75. What they given x value here. Then x naught is 3.5. Already we taken here x naught is equal to 3.5. 3.5 minus 3.5. So take the 3.5 is the origin. The center means we are taking 2.53, 4.0, 4.5, 3.5 there, 3.75 minus 3.5. There is the 0.5 we are taking the origin here. Y is the means 2.5 to 3 is the 0.5, 3 to 3.5 is the 0.5. So 2 by 3.75 minus 3.5 division of 0.5 is equal to 0.5. I'm taking the table. This is 3.5, I'm taking 0. So minus 1, 1, 1, 2, 3. I'm writing the same values here 24.145, 20.043, 20.225, 18.644, 17.262, 16.047. Do the minus 22.043, 24.145. That is these two values minus 2.012. These two values minus 1.818. These 2 point minus 1.851. These two 1 point minus 1.3. 1.382. These minus 1.215. I'm writing. I'm now doing the tabulation work simultaneously here. Then we are doing minus 1.8 plus minus 1 plus 2 means plus 2.84 minus 1.85 plus 1.8 mentioned to minus 2.37 all the pluses. So minus into minus plus minus 1.2 plus 1.5 0.199 minus 1.25 1.382 that is 1.67 again 0.2531 minus 0.284 that is minus 0.047 1.99 0.237 minus 0.038 0.161 minus 0.03. But the both the values is 0.9, this is 6, 0.6 minus 0.9, 0.003. So ut is equal to u naught plus t delta u naught. We are taking the value t into t minus 1 by 2 del square u minus 1. For the second value, t plus 1 into t minus 1 by del cube u minus 1. T plus 1, t minus 1, t minus 2, 24, then 120. 2 factorial, 3 factorial, 4 factorial, 5 factorial, t plus 2, t plus 1, t minus 1. So I'm the first value I'm taking here of the value is 3.5 value, 3.5 center value is 20.225. U naught is equal to M 20.2.5. So T into what is the T value here? What is the T value? Find out here 0.5. I'm writing here 0.5 plus del U Y naught, del U naught, del U Y naught. See here minus 8, minus 8, minus 8, 1.8 either. See here minus 5.81, minus 5.181. I'm writing here. Again here 0.5 minus 5 by 2. Again here 0.237. This is the value. Then again 0.5, 0.5, 0.5, again minus 0.038, 0.009, again minus 0.3. So these values are substituting and calculated here. That is 19.407. X is equal to 3.7. There is a 19.407267. We can take here. Use the cross backward formula here. Interpolate the 1976 we are taking here. 1941, 51, 61, 71, 81, and 91. 12, 15, 20, 27, 39, 52. Take 97 as the origin is equal to 10. The population y in lakhs to be estimate. 1976, 1971. It is the 76, 86, 71. That is 5 by 10. 5 by 10 means 5. From what is the values they have written here? The origin is I'm taking 336. So they have taken as origin 1927. That is 1971. They were taking the origin here. So minus 1, minus 2, 1, 2, 1, 2 we are taking here. 1, 2 taking here. So values I'm writing here 12, 15, 20, 27, 13, and 52. So 15 minus 12, 15 minus 12, 13, 3, 20 minus 5, 27 minus 7, 39 minus 27, 12. Yeah, 52 minus 13, 13. 5 minus 3, 2, 7 minus 5, 2, 12 minus 7, 5, 13 minus 12, 1. So 2 minus 2, 0, 5 minus 2, 3, 1 minus 5, minus 4, 3 minus 0, 3, minus 4, minus 3, 10. So del 5 value. We are substituting the value of the formula. So what is the center? What is the origin here? 27. What is the origin? 27. What is the value here? There is a point. What is the value here? 0.5 into 7. Into 7. So here we are rounding 7. So 1.5 and 0.5. What is the values we are finding here? Into 2 into what is that value? 5 here. The second 5 here. Then again 1.5, 0.5. What is the t values? Then minus 0.5. 6 by that is a 3. Again 2.5 minus 1.5, 0.5, that is a 24. Again minus 7. 2.5, 1.5, 0.5, minus 1, minus 1.5, that is a 10. The simplification is 32.4375. This is a Stirling formula. What is the Stirling formula? Taking the mean of the cross forward formula, fun y is equal to y naught, u del y minus 1, del y naught by 2, plus u square by 2 factorial del square y minus 1, u square minus 1, del cube y minus 2 plus del cube y minus 1 by 3 factorial into 2, u square minus 1 by 4 factorial, del 4 minus 1, and so on. This formula is called a Stirling formula. Stirling's formula. This is the conditions of the terms of delta and mu. We can write here y is equal to y naught by u of u by 1 factorial mu del y naught, u square by 2 factorial del square y naught, u square minus 1 by 3 factorial mu del cube y naught, u square minus 1 square by 4 factorial del 4 y naught, u square minus 1 square, u square minus 2 square by 5 factorial mu delta 5 y naught. The even order differences of del yn are actual number values. The ordered mean, the ordered y naught by u by 1 factorial mu del y naught, u square by 2 factorial del square y naught, u square minus 1 by 3 factorial mu del cube y naught, u square minus 1 square by 4 factorial del 4 y naught. So we are taking here these conditions here. The even order differences del square 2n y naught are actual tabular values, and the odd ordered mean values here we are taking here y naught del y minus 1 del 1 del square y minus 1 del cube y minus 2 del cube y minus del 4 y minus 2. These values del 5 minus 3. These values comes here. This is the one. This is Stirling's formula. Stirling's formula, you can use this one. Same the origin values you are taking and the finding the values here. So one Stirling formula we can use here. This is our center point I am taking here 1, 2, 3. 1, 2, 3, 0.54, 0.554, 939 to the center point, -1, -2, 0, 1, 2, 3. Taking the -1 here, taking the values into, taking the 0 point something, the how many zeros it comes, we can take the 10 power. I'm taking all 10 power -7. Again, we got a calculation that is 0, 0. Substituting the values, these values. The same, the Bessel's formula also. Bessel formula is very useful for the practical interpolation. Then y0, y1, del y0, del square y minus 1, del square y0, del cube y minus 1, del 4 y minus 2, del 4 y minus 2, del 5 y minus 2, del cube y minus 3. So these values are also substituting in the formula. The Bessel's formula also we can same as usually in the unit. The error term. Error terms in the, you have to learn the error term in the Bessel formulas also.